Everyone, we'll get started. All right, so welcome to 6150, Security Evaluation Methodologies. I'm glad you found this room. If it's your first time at Concordia, it maybe was a bit of an adventure, but I expect some people will filter in late as a result of that. Okay, so my name's Jeremy Clark. You can call me Jeremy, you can call me Professor Clark, whatever you're comfortable with. And yeah, so what we'll do in the first half is I'm just going to go over the course outline and all the different criteria of the course, answer what questions you have, and then in the second half we'll do a half lecture and we'll get into the material itself. Some of you are familiar faces from my blockchain course, so a lot of this is going to be a repeat of what I said yesterday, but anyways, that's how it goes. Okay, so the course website is on Moodle. You should be on Moodle already. If you are not on the Moodle, it's either because you're not on Moodle at all, in which case you'd need to activate your student account. And if you're on Moodle but can't see the course, you're not enrolled in the course for some reason, you can come see me or shoot me an email to figure out why that's happening. Okay, so I'll just go into the actual course outline itself. Okay, so we'll have office hours for the course. The office hours are virtual. They're drop-in, meaning you don't have to make an appointment or send me a message. You can just show up. They're on Zoom. You'll join the Zoom link. If you're put in a waiting room, that means there's other students. I talk to you one-on-one, so it's a one-on-one meeting. It's not like a group discussion. And I'll get to you eventually, and you can't really see where you are in line because that's a limitation of Zoom. But anyway, that's how it works. Aside from office hours, come talk to me. Every class will have a break halfway through. That's a good chance. If you have questions, you can ask me stuff. At the end of class, I'll stick around. If there's questions, you can ask me. You can always shoot me an email. I prefer an email anyways. So if it's something that's easy to describe in written text, just shoot me an email whenever you have the question, and then I'll answer it. And so, yeah. But the office hours are there if you need them. The other thing is I sometimes forget about office hours, so I have in my calendar I shouldn't forget. But if it looks like I'm not online, you can also just shoot me an email and remind me, and I'll join. The course itself we'll get into a little later, but it's basically it's a security course. Most of you are probably in the security-based graduate program anyway, so you're taking a lot of different security courses. Obviously, this will be like a sort of subset of security, and so I'll talk a bit about what it will cover later on today. There's no prerequisites for the course, so you can take this at any time. Okay, so the expectations of the course in terms of, usually students are concerned about like how much math is there, how much coding is there, and that type of stuff. And so this course is actually very conceptual. So there's no math at all. And the amount of programming, there's zero programming that you have to do. Sometimes I might give an example that's sort of code-based, so you might have to be able to sort of follow 3 or 4 lines of code as they're displayed, but there's no actual production of code yourself, unless if you choose to do it yourself, like say in the context of a project, which I'll talk about later. That said, if you're in the security side of things, no problem at all. If you're on the quality side and you haven't done any basic security courses, this is your first security course or the only security course that you'll do, then there might be some concepts that we kind of go through quickly. And so you can just sort of go back and just make sure that you're okay with them and maybe do a bit of extra reading or ask me some questions if things aren't clear. You can also ask questions during class itself. Okay, but I've had lots of students from quality that have taken this course and done fine, so it's not a problem. Okay, so there's no textbook. So the courses and the evaluation of the courses will be based just on the lectures themselves. The lectures will be recorded, so I'm even recording this now. It will be on YouTube. It will be made available to you the day after or something like that, whenever I get a chance to upload it. And so if you miss a class, it's not a problem. You can just watch the YouTube video. Or if you're reviewing for exams and things like that, they'll all be there for you to review. That said, if you want to ask me a question that you don't want to become part of the YouTube recording, you can tell me that ahead of time and I'll pause the recording or I'll edit it out. But other than that, I just assume that you're all okay with your voices being recorded. There's no video. When you watch the YouTube, it will just be the screen, what you're seeing on the monitor, and then my voice. And your voices if you ask me questions. Okay, everything else will be on Moodle. So now it's based on slides, so the slides are already on Moodle. There's even recordings from last year. The link might still be live because I kind of copied the Moodle, but eventually I'll replace it with the links for this year. And if you want to find like a lecture from last year because you want to move ahead or something, I don't know why you'd want to do it, but if you want to do it, you can find it pretty easily just using the search bar on YouTube. They're all public, or just find my account and then you'll see them. Yeah, so you'll be responsible for whatever's said in class and whatever's in the slides. And maybe I say something that's not explicitly in the slide, you'd still be responsible for it if it's brought up in class. On Moodle, there'll be some additional readings. So like the way this course works actually is we usually do like kind of 2 lectures on a topic, and then there'll be a completely different topic and we'll do 2 lectures on it. And usually the content for those 2 lectures is from an entire course. So I read an entire textbook, or I took an entire course myself, and I tried to like condense down the most important material and give you like a kind of 2 lecture recap. And in those cases, I still will give you the reference for like the full version of it. So none of this stuff is required reading. So for example, today we'll talk about something called Stride. Stride is from this book called Threat Modeling. And you don't have to read that book. Okay, you just have to know what we talked about in class. But that said, if you want to read more, or you want to do a project that uses it, you're really interested in it or whatever, then those additional readings are there. And so you can drill down and get a little more information. Okay, grading scheme is fairly standard, with one exception is we don't do a midterm in this course, so it'll just be a final exam. And then you'll have 2 assignments and you'll have a project. The project I'll talk about in a bit. I'll circle back to it. The assignments are already posted on Moodle, so you can take a look at them. We sort of do the same assignments every year. The assignments are closely tied to the lecture material. So for example, assignment 1, you'll build what's called an evaluation framework, and we'll talk about evaluation frameworks next class. So you could start looking at it if you want, but it won't really make sense until you watch it or until you go through next class. And then similarly, assignment 2 is based on something called a cognitive walkthrough. That will be covered in lecture 9. And so we'll talk about it in lecture 8, and then I'll give you an example of one in lecture 9. And so you can start working on your project after lecture 8, your assignment 2, and then you can use lecture 9 as just sort of a sanity check that everything is going well. Okay, so in other words, don't worry too much about your assignments, but they are there and the due dates are here so you can take a look at them. And about a week or maybe 2 weeks before the assignment is due, I'll try and tell you, or if I forget, remind me, but I'll go through the assignment itself and tell you exactly what I'm looking for and answer your questions. But for now, don't worry about the assignments because we haven't covered the material anyways. And project, I'll spend a bit of time on the project once I go through everything else. Yeah, okay. So you'll get a percentage. Your percentage will be based on these components. That gets translated into a letter grade. There's no standard relationship. Like it doesn't mean that if you get exactly 91, that means it's an A+ or an A. There is some curving of grades. I've always only curved up. So I've only given you a better mark than the actual numeric number. So I've never had to curve down, so to speak. But I guess in theory, it's possible that maybe it gets curved down. But anyway, so everything is sort of based on distributions of marks and clusters of marks. And that type of thing. That said, at the end of the course, so you'll get your assignment 1 and 2 marks back because you'll submit them during the semester. The project and the final I'll mark, and then you'll just get your final grade, which will be a letter grade. And then you're free to ask me, you can just shoot me an email and say, can I have a breakdown of my mark? And then I'll say, okay, this is what you got on your final, this is what you got on your project. Otherwise, you won't necessarily see these as individual components. If you want to review your final exam, you can also come set up a meeting after, like in the next semester, and review it as well. Okay, this is sort of the outline of the course. So these things won't necessarily mean anything to you until we go through them, but roughly the first 5 weeks, we'll talk about what's called threat modeling. So how do you come up with attacks, security attacks against a system? And so I'll show you 3 methods. One is called STRIDE, which we'll talk about today. One's called evaluation frameworks. It's more of a comparison. So let's say you have 4 different things you can do and you want to figure out which is the best, then you would use an evaluation framework. And then attack tree is another methodology. We'll spend a long time on attack trees. They're probably the most useful of them. And we'll illustrate it with an example, which is called HTTPS. And we'll spend a lot of time on just how HTTPS works in order to understand and build the attack tree itself. Then we'll talk about social engineering. Social engineering is basically someone tries to trick you at a human level in order to accomplish a security goal. So like think about someone who dresses up like a security or like an IT person. They walk into a business and say, I'm here to fix the computers. Can you let me in the server room? And then once they have access to the server room, then it can turn into a technical attack. We'll spend 2 lectures on that. We'll spend 2 lectures on usability. Usability is when a human sits down to use a system, like say you want to use a VPN or you want to use encrypted email or something like that, you have to figure out how to use it, okay? And if there's issues with me being able to do that, then I won't be able to do it securely. So it will eventually impact security, but it's more of a user interface like kind of level. And so we'll talk about the different methods for trying to figure out whether your system can actually be used by normal users and they're not going to try and shortcut it. Then we'll switch to something called policies and procedures. So a policy is like a set of rules, right? Like so say we have a final exam and like you're only allowed a pencil and your bag has to be at the front of the room. Like those are policies, right? And all of those policies there's a reason behind the policy. So in the security world, lots of organizations, corporations, they have all these policies in place. The policies are there to achieve certain security outcomes. Some of them are there. Some of them are for other reasons, but we'll focus on the security ones. And if there's some flaw in the policy, then there might be a loophole or some way of breaking the security through the policy. So we'll do an example where we use airports. We'll talk about airport security. It's a sort of example that we've all probably had experiences with. And then policies also make their way into software. So software is code, but there's rules that are based into the code. Like what should the code do, right? And those are decisions that the designer of the code made. And they could have made a different decision. And based on the decision they made, that could impact ultimately the security. So I'll give you 2 examples based on web tech browsers. So there are decisions that were made in the mid-90s when browsers were just coming on the scenes. One of them has to do with how do you handle cookies. The other is how do you handle things like JavaScript. And when multiple websites are kind of weaving content together on a single page, how do you isolate content from each other? And so there's 2 policies that are in browsers that are interesting, the cookie browser policy and what's called the same origin policy. So anyways, we'll look at that at the end of the course. Okay. There's a bunch of resources for things that you may need, so you can check that out as well. Okay, the other thing I'll draw your attention to is the final exam. So the final exam, I know it's a long ways off, but I'll just say a bit about it. The first thing is I don't have a date for you for when that exam is. I don't even choose the date. It's chosen by the university. They have to look at everyone's schedule and make sure that they can pick a time where there's not like one student that has two courses and has the exam at the same time. So it's something that's chosen by the department. Right now, what we do have is a range of dates, so you can see them on the graduate calendar. This is a good resource for you anyways. I always refer to it for things. But the final exams begin December 4th and they end December 18th. So as of now, it could be any day between those 2 days, inclusive of those 2 days. Generally what happens, the first thing they try and do is, because we're a Wednesday afternoon class, they'll put the exam the first Wednesday after the last class in the afternoon. That's sort of the default, and they try and do that for all the courses. But if there's conflicts, then they may change it as well. So you can't plan on that. Like, don't go buying airplane tickets and travel plans and things like that you can't reimburse based on that like heuristic, because it may not hold. But in general, that's usually what they do. But anyways, the exam schedule will come out in about, it takes over a month, but it might be a month and a half, like kind of mid-October by Halloween kind of thing. You should have a good sense, and then you can start booking any travel that you might plan on doing in December, at the end of December, early January. The exam itself, I mean, I'll talk about it like the week or 2 weeks before the exam itself, but there's some information here. It'll be short answer, true, false. You'll write it on a Scantron, the multiple choice. So you use a pencil. You can bring a dictionary. You can bring a calculator. You won't need your calculator. And then the other thing that students sometimes worry about is memorizing a lot of things. And so you can bring a cheat sheet. So one piece of paper, you can write whatever you want on that piece of paper, and you can have access to it as you write the exam. So no question is going to be a memorization question. They're all going to be conceptual questions. And if you're worried about forgetting something, then put it on your cheat sheet so you remember it for the exam itself. Okay, I feel like I went through that very fast, probably because it's my second time in 2 days going through this. So is there any questions about this stuff? Or more information that you want on anything? I'll talk about the project next, but setting the project aside, is there questions about any of this? Okay. If it occurs to you a question, just don't be shy and you can ask me at any time. Okay, so the project is, okay, so the project's something you'll do. It'll be due on the last day of classes. It's something that you can do as an individual or you can do into groups, and I'll talk about that in a second. The project itself will be a PDF, so it's going to be a written report. Just in terms of logistics, you'll submit the PDF as well as your assignments on Moodle itself. So Moodle will have like a little place for you to submit your stuff, and then it will, and that's how we'll collect it. For your assignments, you'll get your grades back through Moodle. So the TA will mark it and then give you your grades. The projects, because I have like a week to mark all the finals plus all the projects, I don't give you your mark back. It's just would be an extra task. So the only way to get your mark on your project is to send me an email after, and then I'll give you the breakdown of your grade. So you won't get it back through Moodle. You'll just get your final grade by default anyways. If you happen to work with another person or in a group, only one of you has to upload it, not everyone. And it doesn't matter who. Once I have them, I'll just download them as a folder and go through them one by one. And then I'd ask you to name them with your student IDs in the file name, and then just project or something like that as a PDF. Okay, so the project topic itself is very broad. So like I say, it's a written report, so you're going to write something. And it can basically be anything in security, so anything that you want to do. But what I do want is, because this course is focused on evaluation, I do want an evaluation component. So I don't want just a straight security paper that doesn't consider evaluation. What is evaluation? It's basically like if I tell you something is secure, I have a reason for why I think it's secure, right? I can't just tell you it's secure and you're like, okay, it's secure, right? I'll say, well, it's secure because I tested it, or I looked at it from this perspective, or like this is what I looked at I designed it with this in mind. So all of those things are evaluation methods. They're ways of looking at something and deciding whether it actually is secure or not, okay? So evaluation is it's kind of pointless to write a security paper if there isn't a component of evaluation anyways. It's pretty hard to do, or if you do it, you might be doing a bad job with security, because no one takes anyone's word for it that something is secure, okay? So it's not going to be hard for you to work an evaluation component into your project, but it does need to be there, okay? So there needs to be something in terms of evaluation. Now, some students think that means you have to do something exactly like we did in class. So like today you'll see Stride. So I need to use Stride in my project, or I need to do an evaluation framework. You don't need to do that at all, okay? So as long as you're talking about why the system is secure, first off, well, there's two sides to it. What does it mean for the system to be secure? Like, it's kind of vague to just say, oh, we have a Wi-Fi network, it's secure. What does that mean? Like, are you talking about privacy? Are you talking about security? Are you talking about like there's no malware? You can't do denial of service? Like what exactly are you talking about, right? So a crisp definition of what security actually means, and then why people think it's secure. They mathematically proved it was secure. They got a bunch of libraries that tested a whole bunch of different attacks. There's 50 different attacks, and there's this library, and I threw the library at it, and it passed all 50 of those attacks. So therefore, it's secure. Whatever that is, whatever the methodology is, it's going to differ depending on what your topic is. But that's what we're getting at is sort of like, okay, what is it based on the fact that you think that this is secure or not? Okay. So you can have some sort of component of evaluation itself. The report can take one of two flavors. One thing is you can do something new or novel that's never been done before. This would be more like if you're in a thesis-based program, master's or PhD, then you might be looking to do this, the kind of thing that you would do in a research paper. If you're in the course-based project, you've never done research, it might be hard for you to do novel, but you're welcome to try, and I'm here to help you narrow it down as well. But you might prefer what I call a systemization of knowledge paper, which is basically you just pick a topic and you tell me about that topic. Okay, and I have a few points about the difference between that and a survey, but it's kind of like a survey. So for the project, you can do it individually. You can do it 1, 2, 3, 4 people. If you want to do more than 4, you probably can too, but just come see me and tell me about it. And then I just want to see that there's a need that you actually need more than 4 people. And then it's probably okay. But if you don't want to talk to me about it, then by default, you can do between 1 and 4. I will take into account how many people are in the group project. So if there's a project with 4 people, I do expect a deeper project or more work than a project with 1 person. The report itself can be in any template. It doesn't matter. You don't need a cover page or anything. Just title. Everyone who's in it, don't forget to put your name and student numbers. And then you can just jump right into the content itself. It doesn't matter about the margins and font sizes and all of that stuff. As long as it looks reasonable, it's fine. But do limit yourself to 8 pages, okay? If you're at 8.5 or something like that, it's not a big deal. But if you're like at 10 or 11 or 12, I probably will accept it. But again, just email me, and I just want to make sure that you actually need all of those pages. The reason the page limit is in place, well, first off, on a research perspective, if you write papers, there's always page limits. So it's something that you'll have to get used to. But even if you don't do research, it's meant for my own sanity and my own ability to mark your projects quickly. Okay, so you have a class of 100, and I have 2 classes, and everyone gives me 8 pages. I'm already at 1,600 pages or something. And so it's I did the math wrong. Anyways, whatever. It ends up being a lot of work just reading all the projects, right? It's like reading a book. And you probably want your mark back within like a week or two of submitting your project or writing your final. And so anyways, that's the main reason why it's there. Okay, the last thing I'll spend a bit of time is plagiarism. So this is something you'll hear about in all of your courses. It's a big deal at all universities, including Concordia. If there's cases of plagiarism, I don't handle them. It's not like something between you and me. It's something where the department gets involved and the faculty gets involved. And if you are found to have committed plagiarism twice, then the default action anyway is expulsion from the university. So that's how seriously it's treated. So you need to take steps to make sure that you don't commit plagiarism. A lot of students, I mean, it's half and half maybe. Like sometimes it's just like you run out of time, and so that's why plagiarism happens. And the other half is maybe students don't actually understand. Like they think what they're doing is okay, but it's not okay. Okay, so what is okay in terms of plagiarism? So if you're going to copy someone else's work and present it as your own, that's a clear-cut case of plagiarism. So you cannot do that. Okay. A more mild form that's still considered plagiarism is, let's say I'm writing a report and I find another paper that it's on the same topic. And I really like the way that it's written and the way it's presented. And so I copy and paste that text into my report. And I know I can't just present that as my own. So I kind of go through and I maybe delete a few things or condense it, or I change a few words, that type of thing, okay? That is still considered plagiarism because I'm stealing the idea and the presentation of the idea and the sequence and the order and the logic in which that is being communicated. I'm taking all of that and presenting as if it's my own, even if I change a couple words and it's not like word for word exactly the same, okay? So my recommendation to you is if you read something and you want to use it, don't even have it open. Just write it in your own words based on your memory of what you wrote, as opposed to actually copying it verbatim. Anytime you learn something from somewhere else, you need to tell me that, okay? And the way you tell me that is with a citation. Citations, I don't care about format of citations or anything like that. It just has to be there, and if I look at it, it's reasonable that I know what you're talking about. That's the only requirement. And you can use a lot of citations, and you can be very informal and conversational in how you write. You don't have to write in a very formal way. So like, for example, let's say there's a list that I take from another paper, like Stride today, that's a list of 6 things. So, and I think that those 6 things are right. That's the right list. Then I will tell you that. I'll be like, Stride was proposed by Shoshak in 2019, and then it's spoofing, tampering, and then it's very clear that like I didn't come up with that list of 6 things. Okay, I took that list from this paper. Okay, so that's perfectly fine. So you are supposed to take ideas from other places. If you're writing a survey or a systemization of knowledge, my expectation is that every sentence in your report you learned from somewhere, right? And so like more or less there should be a citation almost in every sentence or every paragraph. Like there shouldn't be a lot of text that doesn't have citations, unless if it's sort of your opinion on things. And you can even say that too. It's like, well, in my opinion, blah, blah, blah. And then I'm like, okay, this is this person's opinion or whatever. Okay. So anyway, so that's plagiarism. Now on Moodle, there's some like automated tools that check for it. I don't trust the tools themselves, so I won't. If it tells me that something's plagiarized, it's not like I'm going to report it because the tool told me. At most, it might just flag something for me, and then I would take a deeper look at it. So any detection will be based on my perception of it. It's not going to be based on what a tool says, but a tool might just sort of point things out. Okay. The main thing too is the tool also takes into account assignments that were submitted in past years. So because the assignments don't always change, last year we changed assignment 1, but the assignment 2's been the same more or less for almost 4 or 5 years. And so your ability to get an old copy of someone else's assignment that's taken this course before is very, very easy to do. And so that's the kind of thing that would be checked as well by the tool. Okay. Is there questions on that so far? Okay, good. Okay, so here's just some tips for the project itself. Okay, so what I'd like from you is very close to a survey, but I consider it slightly different than a survey itself. So a survey would be, my goal is to tell you I went out and found 3 papers about topic X, and I'm going to tell you what those papers say. Okay, that's a survey. So like in this paper, this person says this, and then they do this, and then they do this, and then in the next one, they do the same thing. And surveys are useful too. What that does is it lets me not read the paper. I can read your summary of the paper itself. Okay, so it's sort of like a review or a summary of a bunch of papers. That's not what I'm looking for. What I would like is more like a chapter of a textbook where it's like, okay, I'm going to write you a document about this topic X, right? And I don't care what papers you got it from. Like I want to see that you're citing where you got it from, but I don't actually care where it comes from. I just care about how well are you teaching me how topic X works. Okay? And so that's what you want to do. So you want to write it more like a textbook chapter, or like you're explaining to a friend everything you need to know, or you're writing the Wikipedia article about this topic or something like that. Okay? So you don't have to use 3 papers, or you don't have to use exactly 1 paper. Or, like it all depends. Some topics you might use some more papers, less papers. Sometimes you might use academic papers. Sometimes you might be looking at textbooks. Sometimes it might be a cutting edge topic. There's no papers about it. You're looking at websites and blog posts and that type of stuff. It doesn't matter where you're getting the knowledge from. I do expect you to vet it. So just because you read it on the internet doesn't make it true. And even if you read it in an academic paper, it doesn't make it true either. So authors will often, they want to sell you on the idea, so they're going to, play up all of the strengths of the paper. They're going to downplay all of the weaknesses of the paper. They may say things that are wrong, right? It may not even be peer reviewed. It might look like it, or it's some weird journal that, basically every paper gets in, or if you pay $2,000, it gets in. So like, just because it's an academic paper doesn't even necessarily mean it's right. Okay, so you do have to think critically as you're reviewing this stuff, but you're free to cite whatever you think is reputable. Okay, so here's another good point. This is another way I think of it is, let's say you pick a topic A, and you have 3 papers about topic A, and you read those 3 papers, okay? Now you're going to do your project report for me. Pretend I've already read those 3 papers, okay? So I don't need the summary of what those 3 papers say, right? What I want to know is, I want to know, how do you put those 3 papers together, right? Or what do they all have to do with this general topic itself, okay? So anyways. Yeah, and so the other thing is, like, students will sometimes, they'll pick the paper first, and then they'll do the report, right? They'll be like, okay, these are the 3 papers, and this is the report. But what you should do is do it backwards. Pick the topic, and then read everything you can about the topic, and then write the report based on the topic itself. And so there might be a paper you read that has nothing to do with it. Once you get into the details, don't put it in the report just because you read it.
Professor, Philip, may I ask, will you accept recordings or videos of professional firms speaking of how to do things or the proper way to do things?
As a reference, right? Yes, 100%, yeah. So like presentations, talks that are given, lots of stuff are recorded now and put on YouTube. A lot of the industry stuff, it won't be written down anywhere. And so, yeah, the only way to know what's happening in a company would be because someone stood up at Black Hat or something and gave a talk about it. Yeah. Cool. Okay. What else do we have? Yeah, so think critically about what you're reading. There's no requirements on how many papers you read or what type they are. Be skeptical about what you're reading, so it's not necessarily right. Okay, if you don't know what you want to do, right? So what are some topics? Well, one thing you can do is you can look and see what are other people writing about, right? So there's these big security venues on the academic side. They publish 100 papers a year, and there's 4 of them. And so that's 400 papers. Some of them publish even more. And so you can get a sense of what people are interested in. You can look at the proceedings from 2024 or from 2023 and really understand what are people today interested in. And you'll see papers about everything, okay? Like a real wide assortment. So that would be my suggestion if you don't have something in mind. You could go, I list the 4 biggest conferences, but there's lots of other conferences as well. But just go through and look at the titles of papers. You don't read them all. You're not going to read all of the papers, but just look at the titles. And hopefully one or two of them will jump out at you and say, oh, that's interesting. I'd be interested to learn more about that particular topic. Then you can read the paper. Every paper has a related work section. So they're going to say, here's all the papers that are related to my paper that were written before my paper, right? And so you can find all the papers that are relevant just by reading like half a page of the paper that you're looking at. And then obviously if a paper is written at this point in time, it can't cite the papers in the future that will be written, right? The related work won't cover it. But you can go to Google Scholar, you can put in the title of the paper, and there'll be something called citations, and it will give you a list of all papers that cite that paper. Generally, it would be papers that were published after it, or at most like sort of concurrently with it. And so you can then also see, like say you find a paper from 2000, or let's say 2004, that's kind of old now. And so you can read its related work to see all the work in the field up to 2004. And then you can look at the citations on Google Scholar to see all the related work from that point to the present day. Okay, so your toehold into like finding a topic is really as simple as just finding one paper that's sort of interesting. And then you can once you find one, you can find the entire field of papers on that topic pretty easily. Yeah, okay. Now that's just for academic papers, like citations and things like that. Like sometimes academic papers do cite things that are not academic papers. I don't know how well Google Scholar would track that kind of stuff. But anyways, if you want to stay in the realm of academic papers, Google Scholar is a really nice tool. You can also use it to just search for whatever you're interested in. Okay. The problem with Google Scholar is it indexes everything. And a lot of stuff is actually very low quality, not peer reviewed. And it's difficult for you probably sitting there like looking at research for the first time to know the difference. Once you're in the field a while, you kind of start recognizing names and institutions and venues and conferences and things like that. But it can be difficult for you to decide, okay, is this actually a good paper or not? So anyways, keep that in mind if you're just randomly Googling things. One indication that's they usually will show you the most highly cited papers first, right? And so if a paper has 100 plus citations, it's a good paper, more or less. That's a pretty good rule of thumb. Maybe there's a few small exceptions, but that would be a good way of gauging that a paper is good. But maybe it's a really good paper that doesn't have a lot of citations, and that could just be because it's brand new. So, citations build over time. The paper has to be around for a while. So anyways, you can take it with a grain of salt, this whole citation thing, but it's something that you can give consideration to. Okay, in terms of like, what do you have to tell me about your project? The answer is nothing. So I just need the PDF from you the day that it's due. Other than that, we don't have to ever have a conversation about your project. Maybe multiple people do the same kind of project or the same topic, and that's fine. There's no like, I don't approve the project topics or anything like that. That said, I am here to help, and I want to help you with your project. So if you have questions about it or you want help narrowing down the topic, come to me, whatever, in the middle of class, at break or after class, or send me an email, and I'm happy to talk to you about whatever it is that you want to talk about. The one thing, though, I won't review any rough drafts. So if you sort of do a rough draft and you want me to look at it, I will look at it for 2 minutes and tell you what I can see, but I can't read it all the way through because I just can't scale that up to every student wanting that type of review. Another piece of advice that you don't have to follow, but I find it's useful, is if you think of your project topic as a question, then that often makes it a lot easier to do the project itself. Then it becomes, you basically, what do you include? I read this paper, what do I include from this paper in my project? Well, what is it that helps you answer that question, right? If it's not helping you answer the question, it's kind of related, but it's sort of on a side topic, then don't include it, right? And so thinking of just like the title of your paper is a question, and then the report is the answer to that question, that will put you on the right track of doing more of a systemization of knowledge as opposed to a survey. But again, you don't have to do that. There's no marks associated with doing that, but it's a little trick that a lot of people do that works well. Okay, security is broad, so you can think about security in all sorts of domains. You can pick things that you're interested in, your side interests, and you can probably find some security application. I like things. I don't like reading another paper on the 5 different ways of doing intrusion detection or whatever. Like, there's certain topics that students gravitate to, and every year there's 3 projects on those kinds of topics. If you pick something weird that you think no student has ever, wrote about in the history of this course, I'll be very happy to read it. It'll put me in a good mood. But again, it's not strictly necessary, but anyways, try and be creative, try and think of something that's actually interesting. It will make it easier for you to research it and make it easier for you to write the report if you're actually interested in it or you think it's interesting, rather than picking something that you think will just get you a good mark, because it won't necessarily. Another thing I mentioned is that a lot of the work of the project is actually coming up with the topic of the project. So it's not like you're going to spend an hour, you're going to come up with the topic, and then you're going to spend the rest of your time writing the report. You might spend 10 or 20% of all the amount of time you put into this project. It might take 10 or 20% of that amount of time just to come up with the topic. Okay, and so that's normal. That should be expected. And so, spend some time trying to really get a good topic. If you can get a good topic, it will be a good report. Like I say, it'll be easier to write. It'll be easier to spend some time working on it. You'll actually be interested in it. So do plan on taking your time choosing the project topic. And then I mentioned this already. You don't have to use something specifically from the course. So a lot of students will like try and use an evaluation framework because that's what we covered in class. So that's not necessary at all. As long as you're talking about what security means and why people think it meets that definition of security, then it already covers evaluation. If you're not clear on whether it qualifies as evaluation, that's what I'm here for. So you can say, I'm doing my project on this, and I'm just not sure about the evaluation component. And then usually my answer is always like, well, this is what the evaluation is, and you're already doing evaluation if you don't call it that. Yeah, and in particular with these things, another sort of pitfall is you don't know what these things are yet, but don't feel that you need to use more than one. So I would rather have you do one idea, one methodology, like everything. I'd rather have a deep dive on one small thing than like a paper that's all over the place. It's like, now we're doing stride, and then usually this happens because there's a team of people. And so we're like, okay, we're studying whatever, and you're going to be the stride person, you're going to be the evaluation framework, and you're going to do the cognitive walkthrough, and then we'll kind of glue it all together. And those papers projects don't tend to work very well. They're not very cohesive and coherent. And there's often not a need to do all 3. And I would much prefer that, there's a lot of effort that gets put into one thing rather than sort of split across different things. Okay, the grading scheme you can see here. I'll just sort of break it down for you. So scope and execution is just sort of like, is it a good question? Does it make sense? Are you sticking to the topic? Is there a logical flow to it? Like that type of thing, basically. Like how sort of comprehensive is it? Are you skipping over things? Is there things that you're missing? That type of thing. Interpretation is sort of my trying to read into your report how much you actually understood what you're talking about. So it's very easy for technical things even to read something, not really understand it, but you can repeat it back because you read it, right? But if you don't really understand it, when you repeat it back, you're not going to explain it very well. It's very easy to skip over things because you don't even know that you're skipping over them because you don't really understand what it is. And so there's a writing style that is apparent to me anyways after like reading hundreds of these reports where I can just sort of tell that people are repeating things that they read, but they don't really understand what they're saying. Okay, so that's more or less what interpretation is. So I don't expect you to become world-class experts on something. And often the academic papers you're reading are from the world's experts. Like these are people that have been looking at that for 20 years, right? And they eat, sleep, breathe this. and you're going to look at it for 3 months in the course of a course, you're not going to be an expert, right? And I don't expect you to be an expert, okay? And it's also okay for you to say, I didn't really understand. I read this, and this is what the authors claim, and to be honest with you, I don't really understand it. Like, there's a bunch of math, I didn't follow it, but this is my understanding of the paper. My understanding is this, that it does this, or it guarantees this, or these properties, and this is why they say it does. And, you know, I don't have a PhD in the topic, so I can't say for sure whether they're right or wrong, but this is at least what's being presented. So that's okay, okay? So you don't feel like you have to sort of punch above your weight in terms of how technical you make the paper, okay? That said, there will be components of a technicality component. So I do want to see a graduate level kind of report. Technicality means different things. Like if you're doing crypto, it might be math. If you're doing programming, it might be code. Like, you know, there's different levels of technicality. For me, what it means in a course like this is just that you aren't afraid to go into detail when it's warranted. Okay? So you're not going to gloss over details. If there's something that's sort of complex, you won't say, oh, it's kind of complicated, don't worry about it. Okay? You'll go through it, you'll find a way to simplify it, and you'll go through those details. Okay? So just sticking with the details, whatever that means for your project topic, that's what makes something technical. So it's precise, it's correct, and it doesn't shy away from complexity. And then there's some marks that are pretty easy to obtain that are just with like kind of the presentation of the paper. Does it look kind of polished? Is there good section headers? Is it kind of like split up in a nice way? Do you use diagrams and figures to like try and simplify concepts? You know, are the figures like actually helpful? Like I look at them, I'm like, okay, this actually helps. This really helps me understand it. Or are they sort of pointless figures that are just sort of there to make it look like like there are some figures there? Yeah, so anyway, so that's sort of the manuscript side of things. And then there could be general deductions that I don't necessarily tie to one of these categories. But yeah, that's more or less the grading scheme. Okay, so that's what I want to say about the project. Are there questions about that? Or about anything in general, any of the logistics of the course at all? Don't be shy, ask them. Yeah.
So like if you want to use programming example, the code might be big, so how we can tidy it up within 8 pages?
Okay, so if you do an implementation or you study someone else's code, yeah. So in both cases, you'll see this yourself when you read academic papers. Like, there's tons of projects where the contribution is like we coded up this big thing, or we looked at this software that already exists and we found these vulnerabilities, or whatever the case may be. So the trick is that, first off, you're not going to put the code in the report itself. So there might be a link to like GitHub or something that has it, but you're not going to put the code in. What you might put in is like snippets, like this is the critical piece or this type of thing. And if you're designing your own code, it'll be more about the design of it. Like we have this class and it talks to this class or whatever. It's sort of the high level architecture of the system. And then you'll talk a bit about like the challenges and this was hard and this was easy and that type of thing. And this is the performance or whatever. So written reports about code tend to be about sort of the surface of the code, not necessarily about the code itself. Or if it's about the code itself, it's very selective. So they usually only highlight the things that were difficult or counterintuitive or something like that. You might highlight those types of things. But you won't do like you can't do a full walkthrough of the code. And it's not meant to be like a developer's guide or something like that, where you're like, okay, here's the function, here's the API, and this variable means this. Like that's not the kind of thing. You want to talk more about the design and the purpose of the code in that sort of a higher level. Does that make sense? Yeah. So you're free to do programming if you want, or you can do zero programming for your project. It depends on you and your skill set and what you think you want to do for your project at all. So there is no programming component that's expected, but every year there are people who really like programming and they'll do things that are either developing new systems or analyzing systems that already exist. Other questions? Okay, good. Okay, so the way that most lectures will work is they're pretty long, right? They're like 2.5 hours. Although I think maybe now they're even longer because we moved from 13 lectures to 12. But anyways, I'll keep it at 2.5. And so normally I'll split it in half. So we'll do about half, like an hour and 15 minutes or so, and then we'll have like a break, 10, 15 minutes, and then we'll come back and do the second half. So for today, what we'll do is we're going to do the break a little early, but I'm going to go into the content itself. The lecture that I have for you isn't going to probably take the whole period of time, but starting next week and the week after, we will more or less utilize the full class time for each of the lectures. So why don't we take 10, 15 minutes, well, let's say 10 minutes. So come back at 10:02. And then we'll go into a little bit of the lecture and then we'll call it a day. Hi.
If you add images, how to add images?
Okay, so for the first lecture of the course, we're going to look at something called threat modeling. So this is going to be the first methodology that we see. It's going to be a pretty high-level methodology. As you see, high-level limits its usefulness, but we'll go through these details. Okay, if everyone can quiet down, please. Okay, so in one slide, what's the goal of this course? The goal is, like, let's say that you all graduate, you're all experts in security now, and you get a job, and you show up on the first day of your job, and you're going to be handed something, and because you're the security person, they're going to ask you, is this secure? Okay? And you're going to have to answer that question, and it's not something that you're just going to think about and then say yes or no. It's like you're going to have some reasons for why you think yes or no. You're going to have some methodology. You're going to have some way of testing it. Okay? So how do you even get started answering that question? Right? Like where do you even start? And so what I'll give you at least at the beginning of the course is a couple high-level methodologies that at least give you somewhere to start. But for reasons that I'll go through, they might not be sufficient to fully answer the question. In fact, they won't be. But anyways. Okay. So the first thing that makes this sort of hard to do, first off, this is a very hard thing to know how to get started answering this question. And one of the reasons it's hard is because X could be lots of different things, right? You go work at a software company, so they hand you an app and they say, is this secure? Or they hand you a driver for the operating system and they ask you if this is secure. Or you look at a kernel, right? So those are all completely different things. They would require completely different skill sets, but they would probably be like fairly close together because at least they're all software, okay? But you're not necessarily given software. You could be given a piece of hardware. here's an IoT device that people are going to carry around, or here's a fridge and it has some internet capabilities, and is this thing secure or not, right? From a hardware perspective, right? And so the methodology that you use to try and figure out whether the kernel is secure and the methodology that you use to figure out whether the fridge is secure, are they going to be the same methodology? Probably not, right? You might use, I don't know, static analysis or some coding tools for the software, but that doesn't work on hardware, right? So is there like a methodology that works for everything? Okay, so that's a question that we can think of. What are some other things besides software and hardware that you could be handed and asked if they're secure? And we're not leaving until I get at least 5 from you. Okay, so it could be some sort of physical security, locks, security cameras, all of that type of stuff. Okay? Say policies, yep. So it could be procedures, policies, that type of thing. So it doesn't have to be hard technical things. It could be something soft like that. Sorry, say again? Yeah, networks. So sort of between maybe software and hardware, depending on what you're looking at, but it's often considered its own category. So everything to do with networks, whether it's against denial of service, traffic shaping, inspecting content as it goes through, ensuring liveness, all that kind of stuff. Just shout it out really loud.
Infrastructure.
Okay, yeah, infrastructure. So like it could be critical infrastructure, cyber physical systems, smart cars, the power grid, all of that kind of stuff. So how you look at whether you go work at Hydro-Quebec and they're like, okay, here's our power grid, like, can you help us with the security of it? Or you go work at a small software startup and they're like, here's our new iPhone app, right? Those are very, very different things, right?
Would we consider identities?
Okay, so identities, yeah. So that will be a component as well. And that kind of goes along with people, right? So like whether you can identify people or authenticate them. Can I pretend to be someone else? Right? So that could be a break in the identity protocol, or it could be that we don't really authenticate people. I assume you're the IT person because of what you look like. So it could go into like social engineering. Usability could also be in terms of people, like in terms of how well people use systems. Okay, so these are all great things. I think you covered almost all the ones that I thought of, and this is not meant to be comprehensive at all. Okay, this is just some random things off the top of my head, just to encourage the idea that security is pretty broad. So networks, we mentioned. Protocols is one that maybe we didn't mention. So like the math, like does this crypto actually work? Is the crypto algorithm secure? That type of thing. Data could be its own category too. If I have access to this data, what can I infer about it? Health data, privacy, things like that. Physical, lock, surveillance. Organizational, so policy, procedures, humans, social engineering, usability, and you can probably think of a bunch more now that you see this list, okay? But the point is security is very broad, and one of the goals of this course is also to not focus on, like you'll take a network security course and it will all be about that network. You're going to take an OS security course and it's going to be about software, mostly OSs, maybe some apps, kind of things. And so, and you'll take a crypto course and that will focus just on protocols. So part of this course is I'm trying to get you to look at security, not just as protocols or software or things like that. I want you to start thinking about everything, like look at it from all the different angles. And then I'm going to put the emphasis on things that kind of fall through the cracks. So no other course is really going to look at humans and their involvement in security. We're going to spend a lot of time on that as a complement to those courses. Or no other courses really think about policies and organizations. So that's something that we'll look at as well. Okay, so security evaluation, this course is kind of hard to teach because I can't give you an evaluation method that's going to work for all of these things. There just isn't one, period. Okay? Or alternatively, you could argue, actually, there are some methods that do actually work for all of these. In fact, the one I give you today is called Stride, and it does actually work for all of these. The problem with it is it's so high level that you can't really make any progress with it, right? It's a good starting place. You can sort of brainstorm like kind of what you want to do and what you want to look at, but you're never going to use this methodology to actually answer, like it's not the methodology you would use to figure out whether a driver has any vulnerabilities or not, right? It's just a high level kind of methodology for thinking about things. Another problem with methodology is, imagine you're hired and you're like, okay, you're the security person. I want you to figure out if this middle box is secure or not. And you don't know anything about networks other than you took 6120 or 30 or whatever it is. Okay? You're not going to be able to answer that question. Okay? So there's no getting around the fact that you can't really think about security of a system until you understand the system itself. Okay? So that's also, it's hard for this course because, we can't do a deep dive into a methodology without learning the details of the system that underlie it. So for example, I'll teach you about attack trees. We'll spend 3 lectures on that because we're going to apply attack trees to this protocol called HTTPS. And in parallel to understanding how attack trees work, you also have to understand how HTTPS works. Okay? So I'm going to teach you how it works sort of in parallel as we sort of develop the attack tree, and that's why it would take so long. And that's, again, we're spending 3 lectures. That's a lot of hours. And at the end of the day, we just have one attack tree on one little protocol. And it's not even covering the whole protocol. It's only going to attack one aspect of that protocol. Okay? But it is probably the closest to the kind of thing that you might do where you actually try and do a deep dive into one of these methodologies. So the analogy that sometimes people say is that like there's these experts in identifying counterfeit bills, and they don't spend a lot of time looking at examples of counterfeit bills. They spend a lot of time looking at real bills, and then when they see something that's counterfeit, it just looks funny. It doesn't look exactly right. And so it's sort of the same here, where you spend a lot of time looking at the real thing, and then you understand it, and then when you see something wrong, it's almost, you sort of intuit it, or you feel like you just get a feeling that there's something wrong here, and then you devote more attention to like trying to figure out where that's coming from and whether it's sound or not. Another thing is that security, we say it's necessary but not sufficient. So at the end of the day, you can never say something is secure. Okay? What you can say is there's a bunch of attacks on the system that we've thought of, and I can tell you that it's not vulnerable to any of these attacks. So there's 10 attacks on the system, and I tested it against all of these 10 attacks, and I'm pretty confident that this thing is not vulnerable to any of those 10 attacks. Does that mean it's secure? Well, it means it's secure against what we know, but it doesn't mean it's secure against the 11th attack that no one's thought of yet. I wasn't able to test it against the 11th attack because it's going to take 2 years before someone clever comes up with that attack. Okay? So security, at the end of the day, you can think of it as sort of like a laundry list of like, okay, it's not vulnerable to all of these things that we thought of, but it doesn't mean that there's something we haven't thought of. Okay? So that's the best you can do, and we live with that. Okay? So all systems that we consider secure, or if they get like a security certification from the government or something like that, it's all based on this approach. So they're not saying, it doesn't actually mean it's secure, it just means that it's that all of these classes of attacks don't apply to this particular system, but there could be some new way of looking at it. Okay? And a lot of the topics we think about pick up on these things. Like, for example, if you're talking about software, people don't think about the user a lot. They just think about like, at a security protocol algorithm level, it's secure, but you sit a human down and they're pressing the wrong button, or they're doing the wrong thing, or they're sending you their private key because they think that's what you need to like, check their signature when you really need the public key, and they don't know the difference, right? And so it doesn't matter if the crypto's secure at that point. The human made an error, and the system as a result isn't secure because the human made an error, right? So that would be an example type of thing, okay? So security is sort of like proving a negative rather than proving a positive. So it's just like, it's not vulnerable, not vulnerable, not vulnerable, doesn't necessarily add up to it is secure. Okay, and then I sort of mentioned this point already, but there's no one methodology that's going to work for people and procedures and cyber physical systems and software. Okay, there just isn't a universal methodology, or if there is one, it will be so high level that it's not really that useful for doing anything other than some high level brainstorming, which is still useful, right? And I will spend half a lecture on one of these super high level methodologies because it does have some merit, and it's a good place to start. It at least lets you start thinking about things. Okay, so these high level methodologies. They're useful because you can look at software, cyber physical, or humans or whatever. You can look at all sorts of different things using them. The downside is that they're not going to give you a deep dive on anything. And they're best just for like getting organized, or let's say you're reporting to someone like your findings of whether something's secure. It might be a way to sort of organize your report around different categories of attacks and things like that. So that's what these things are useful for. So we'll do 3 examples in the start of the class. So today we'll talk about something called STRIDE. Next class we'll talk about something called evaluation frameworks. And the couple classes after it we'll talk about attack trees. Attack trees are maybe not that high level. They're high level in the sense that you can do them about anything. But the actual mechanics of doing an attack tree actually gets pretty low level. So it's not necessarily a high level. It's a universal methodology that you can use for almost anything, but you can do it in a way that is actually quite deep. So it's kind of a nice balance between these. Whereas evaluation frameworks are pretty high level by definition, and STRIDE is, as you'll see, very, very high level. Okay, questions about any of this? Okay, so STRIDE is basically what it is an attempt to say there's a bunch of attacks and different attacks do different things, so can we come up with some broad categories for the attacks? And so the idea of STRIDE is it stands for something, so each letter in STRIDE stands for something. And there's 6 different categories of attacks, and the idea is that most attacks would fit into one of these 6 categories. Okay? You could think about it the flip way too. You could say, well, a secure system would try to achieve a bunch of properties, a bunch of security properties, right? So like say I have secure messaging. What does that mean? Well, it could mean that the messages are kept secret, right? So that's like one property that I might want to achieve. But it could also mean, if someone changes the message, I send a message to someone, it gets changed in the middle, that person would be able to detect it. That's not a privacy thing, that's an integrity thing. That's a different thing, right? Or I'm sending a message to you, how do I know it's going to you and not someone else? That's authentication, right? You can think of it from these sort of property perspectives as well. So that was the original idea. So you might see this in a lot of security courses. First lecture are going to show you the exact same thing. 3 basic properties you might want are confidentiality, integrity, and availability, or CIA. So confidentiality, secrets stay secret. Integrity means that there's some correctness or soundness. And availability means that it doesn't go offline, more or less. So STRIDE is exactly the same as CIA, except for it just thinks those 3 are good, but there's a couple things it doesn't really cover. It doesn't really cover authentication, right? Like I know who the person is. That maybe you could put it under integrity, but it's kind of its own thing. It doesn't really do good on authorization. Some people will say CIAA or AAAA, meaning authentication and authorization added on to the end. And so eventually you come up with, more or less the 6 things. So STRIDE is exactly this. It has these 3, plus it has 3 other ones that it feels missing. And then it also flips it around. So instead of it being based on the property, it's based on the attack as opposed to the property. So you could add authentication, authorization, non-repudiation. And so this is what STRIDE stands for. So the S is for spoofing. So that's the attack. So from the attack's perspective, it's a spoofing attack. And then from the property that you would want if you were not vulnerable to that attack. So if I secure my system against spoofing attacks, then I would say I have authentication. So authentication is sort of the flip of spoofing. The T is for tampering. The flip of that is integrity. Repudiation, the flip of it's just called non-repudiation. I'll tell you what that is in a second. It's kind of a weird one that you might not know just based on the English word. Information disclosure is the flip of confidentiality. Denial of service is the attack on availability. And there's something called elevation or escalation of privilege, which, again, I'll sort of go through one by one. Okay, so the goal here is to I'll sort of go through them one by one. These are kind of more or less straight out of the textbook. Every year I'm like, I need to redo them so they make more sense. And then every year I forget, and then it's the first lecture, and then now I'm realizing, oh yeah, I forgot to do that. So they're kind of written in a weird way. So I'm not going to go through cell by cell or line by line. Instead, I'm just going to try and tell you at a high level what each of these things mean, and you can look at these as examples, and eventually I'll fix the slides. Okay, so spoofing is an attack on authentication. It's basically you impersonating someone else. So you're pretending to be someone that you're not. And spoofing doesn't have to be a human thing, okay? It could be a data thing. It could be a file name. So sometimes the operating system will go and it will try and find a file, right? So if you can stick a file there instead, or something along the directory path, or maybe there's a link, like a symbolic link that the operating system's following to grab that thing. If you can change that link to point at your file instead, then you spoofed that file, right? Or it could be a process name. It could be a domain name, right? Maybe you go register Google with 3 O's instead of 2, and you send people spam, and they're just looking quickly, and they say, oh, that looks like google.com, but it's really Google with 3 O's. Okay, so these are all examples of spoofing where you're trying to impersonate someone else. Okay, spoofing. Okay, in general, when we think of security, we usually start at the human level. Like we think about our social interactions and things like that. And sometimes we make the mistake of thinking, oh, computers are kind of like that. It's just sort of a digital form. But sometimes there's things that happen in the computer system that don't really have like a good sort of analog in the real world. And then as a result of that, we overlook them, right? So like I'll give you one example. The examples are called race conditions, which you may have heard of. This is a popular category that has a really fancy, weird-looking name. And so this stands for time of check versus time of use, okay? And there's a huge category now, if you go through CVEs and things like that, a lot of vulnerabilities have this as a component. So most attacks don't boil down to one thing. They usually involve 50 things chained together. But these types of vulnerabilities tend to show up quite a bit. So what is it? So let's start with the sort of human social example. And it doesn't work in the real world, but I'll show you why it doesn't work, and then you can think about whether it works for a computer. So let's say I go to the club or the bar, and I have my friend with me, and my friend's underage, so they can't get into the bar. All right? What stops them from getting in the bar? Why can't they just go into the bar? They're underage. Why can't they go in? Their face, what about their face? Like they look young? Their appearance, yeah. So it could be, okay, first off, who's checking their appearance?
Your ID.
Okay, your ID. Okay, so it could be matching your face to an ID, and your ID has your birthday, or it could just be based just generally like you look like you're younger. Okay? All right, so here's my idea for getting my underage friend in. What I'm going to do is I'm going to stand in line, and there's going to be some sort of bouncer, and they're going to ask me for my ID. Okay? So I'm going to hand it to them, and what they're going to do is they're going to look at my ID, and they're going to look at my face and see that my face matches the ID. Then they're going to look at my birth date, and they're going to think, 1981, yeah, okay, they're over 18, right? Then they're going to hand the card back to me, and then I can walk into the bar, okay? So there was a check. They checked the ID. They checked 2 things, my face, they checked my birth date, and then the use was like me walking into the bar. I now authorize I'm allowed to walk into the bar, okay? So here's my idea. My underage friend and I are going to switch positions really fast. So he's going to check my face, and when he does that, he's going to check my birth date. And as he's looking at the card, my friend is going to stand where I was standing, and then the bouncer will hand the card back to my friend instead of me, and then my friend will go into the bar. Okay? Does that work? Doesn't work, right? Why doesn't it work?
Because you can't switch.
Okay, we can't switch that fast. Okay, now I'm a computer. Okay, I'm checking whether a file is the right file. So I'm going to take a hash of that file and I have what the hash should be. Okay, could that file switch after the hash is checked and before that file is loaded? 100%, right? Operating systems, they get interrupted, then someone else gets to do something, someone else, and then it goes back to the process, right? You can switch a file reference, more or less instantly, right? So that's the kind of thing that could happen very easily in a computer if you're not protecting it, right? So what you would have to do is lock that file, you check the hash, and then you would load it and then you release the lock after you loaded it, just to make sure that that's all atomic, because you can get interrupted at any time and things can happen instantly. Okay, so that's the kind of thing where we're not used to that kind of thing because we live in the real world. We don't live in the world of computers. And so when you're a developer and you're programming these systems and you're doing these authorization checks, right, it's an easy thing to miss because you're not thinking about the fact that anything can get interrupted at any time and the complete state of the computer could change by the time you get back control and it's your turn to execute again, right? So anyway, so that's one example of time of check or time of use. Race conditions are it's a general case of race conditions in general. And then there's lots of other things that can get spoofed. So addresses, DNS records, then there's people, roles. So these are all examples. Okay, tampering is probably what you think of as security, right? If I tell you security, it's kind of the most logical one. It basically means that you go in and change things, right? You go into a computer, you hack it, you're making modifications to it in order for it to do what you want it to do, okay? So this one's pretty clear. You can modify anything electronic. This focuses more on software, but it could be hardware. You can tamper with hardware. You can remove components. You can shortcut components. You can trick sensors into thinking the wrong thing, and that results in some sort of changes to the system. There's all sorts of very elaborate things that you can do in terms of tampering. There's some more examples. Okay, repudiation's a little weirder, something you might not have thought much about. So repudiation has to do with, whether you did something, like you say that you did something, did you actually do it? Or you say you didn't do something, did you actually not do it? Okay, if you lie about that, we call that repudiation. And if we have a system where you can't lie about it, then we say it enforces non-repudiation. Okay, so here's an example. So I order something on Amazon. I get a new coffee machine. It's a couple $100. It's pretty expensive. I get it. It's delivered to my door. And then I call up Amazon and say, I never got it. Right? I want my money back. It never got delivered. I don't know. Someone stole it. I don't know. I don't know what happened. I just know that it didn't show up on my door. And then Amazon says, okay, you know what? We don't know either. This is maybe Amazon 5 years ago. Like we don't know either, but we'll give you your money back, right? So now I have the $100 back and I have the coffee machine both. Okay, so that's repudiation because I was able to lie about that. Now what Amazon will do is they'll take a picture of it sitting on your porch, and then they'll say, well, we have this picture that was at least on your porch, and if someone stole it off your porch, that's your fault. That's not our fault. We actually delivered it. Whereas before, but there's still stuff like where there maybe isn't enough evidence, or maybe they forget to take the picture. You're like, I'm going to take advantage of the fact that they forgot to take the picture or whatever. And so these are examples of repudiation kind of attacks. Now the main, well, first off, a lot of companies will just absorb this because, the first time you complain, it's fine. You can get away with it. But the 10th time you complain, then they're not going to let you get away with it, right? And so they just have a certain amount of money that they're tolerating to lose. The main thing against repudiation, well, think about the Amazon example. How do they enforce non-repudiation? Well, they take a picture and they email you the picture and it's stored. And so you can think of that as a kind of log, right? It's like a log of the events that occurred, and you have the tracking information, and it was put on this truck and all this stuff, and there's a picture of it at your doorstep. So generally, when we think of repudiation attacks, it's usually on the logging system. So it's the main thing that thwarts it. So any kind of attacks where you could get detected because it's logged, and now you want to do something to make sure that it's not logged, or you want to modify the log, or you want to stick some garbage in so that when you parse through the log, it gets skipped over. All these types of things are sort of repudiation-based attacks. These tend to be pretty narrow, so they're usually just on logging systems. They don't tend to show up in other components, but it's still an important aspect of security. Okay, information disclosure is maybe the other thing that you think of, the big category of security. So this is all your privacy stuff. So we have secrets. We want our secrets to stay secret. I have a password. I don't want you to know my password. I have a credit card number. I want to buy something. I want the merchant to know the credit card number so they can expense it, but I don't want everyone between me and the merchant, including Concordia's Wi-Fi router, including all of the backbone middle boxes along the way. I don't want them to know my credit card number, right? So how do I do that? Well, whatever. Maybe I use cryptography in that particular example, but in general, we have all these security mechanisms to make sure that information stays private, or some people are allowed to see it and other people aren't allowed to see it, and we want to make sure that the right people see it and the wrong people don't see it, okay? So data is probably the most common example, but it could be other kinds of things, and we'll see, for example, Heartbleed is an example that we'll go through in detail later. And yeah, I think this one's like pretty intuitive. Denial of service, also something that you've heard about, you'll hear about it in the network, in your network course. And so it's basically like you're going to eat up the resources of the system and you're going to try and grind it to a halt. All right, so it might be, I want to take you offline, so I'm going to take you offline by just throwing so much network traffic at you that by the time you sort through all of it and decide it's garbage and you can throw it away, you miss all the real messages that were mixed in of people actually trying to connect to you. And so you can't respond selectively to them. You have to look at everything in order to find them. It could be like overwhelming a computer. There's some service I don't like it, so I'm going to, it allows me to, it does some computation for me, so I'm going to give it like something that's like really hard for it to solve, and I'm going to ask it to do it 1,000 times over because I know it's just going to eat up the resources of the system, and eventually it's going to crash and go offline. It can also be against business logic, so like, or policy, so it can show up in that sense. So like, I don't want you to check your email. I know your email address, right? What do? I just try and log in and make up fake passwords 10 times, and then you're going to get locked out of your account for 2 days. And you're not going to be able to check your email for 2 days. And then in 2 days, maybe I'll do the same thing. Okay? So that was because Google or whoever your email provider is, they put in that policy, and as a result of that, I'm able to lock you out of your account. All right? The common way of doing network-based denial of service, I actually have some slides to explain it. It's kind of interesting. I'll actually just walk through the details. So at a networking level, the old school denial of service attack was, there's a server, I want to take it down. I'm just going to hit it with as much traffic as I can. Okay? And if my traffic's bigger than its incoming traffic, if my bandwidth exceeds it, then I'll bring the site down. If it has more bandwidth than me, then I won't. It'll be annoying for the site to deal with, but they can deal with it. Okay? Now, the problem is that most targets probably have more bandwidth than individuals. All right? So this denial of service kind of goes away as companies get more and more bandwidth. So then what the adversary says is, okay, now I'm going to enlist a bunch of friends, right? So I'm going to throw all my bandwidth at it, and I'm going to get 10 other people. I'm going to rent them. People get malware on their machines, and then the people that put the malware on the machines, they auction off the ability for anyone in the world to rent that machine for 1 hour, and they can do whatever they want with it for 1 hour. And it's very cheap, right? So I can go get 1,000 or 10,000 machines, not pay a lot of money. I get them for an hour, and for that hour of the day, as long as the actual person doesn't turn it off or notice that something's weird with the computer, I'll be able to direct their network traffic at the server. It's coming from all over the world because everyone gets malware. It's not, it's just people in Canada. And so you have these computers all over the world, and so it's even hard to block big blocks of IP addresses and things like that. Okay, so we call that distributed denial of service because we're distributing the attack amongst multiple people. So this works pretty well. It still works actually pretty well. But now what Concordia will do is they'll hire someone to sit out in front of the server. So they'll hire Cloudflare or some big company that does all this network management for lots and lots of companies, and it's their job basically to have more bandwidth than any amount of bandwidth that people could throw together into a denial of service attack and try and mitigate it. So then people are like, okay, this sort of, it kind of works. It depends on the website itself. So I can take down small websites with this, but once a website gets taken down this way, then they go out and they hire Cloudflare or whoever to sit in front of them, and this attack doesn't work. So then what people did is they shifted to this new idea of amplification that I think is really cool. So before going into what this has to do with denial of service, just consider in a high level, if you're interacting on the web, basically what you're doing is you're sending requests to websites and they send back a response. So I'm like, give me index.html, and then I get this HTML file. And then this HTML file has a bunch of images. And then I'll go to the servers where those images are and say, give me photo.jpg and logo.gif, and then I'll get those files back, okay? So the whole web works on request, response, request, response, request, response, right? And sometimes you have requests, and you can think it from a data perspective, how long is the request? Like, give me index.html, that's pretty short. I just have to literally say that, right? But then the response I get back, the actual index.html could be a big file. Okay, so responses can be short relative to requests can be short relative to the responses, or vice versa. There's not necessarily a correlation between how long, long requests aren't longer responses, or vice versa. Okay, so my initial idea is I'll say, hey, give me index.html, and I'll go to a website, I'll say, give me index.html, but when I go to the website and say who I am, I'm actually going to say the name of Concordia, which is the server that I want to take down. Okay, so I'll go to this website. I'll be like, give me index.html, give me index.html as fast as I can, and then it will start sending index.html to the website. Okay, and that file is a lot bigger. I can request it because it's really short. I can request it very frequently. And as long as the website can keep up, it's going to send these, at the same frequency, it's going to send something to Concordia, but it's going to be way bigger. Okay? So this is a really nice idea if you're an attacker. There's only one problem with it, which is before I can ask for index.html, I have to do a handshake. And what a handshake means is I have to do a round trip of it. And if I try and do a handshake and I've spoofed the IP address, then I'm going to say hello to the server. The server is going to say hello back, but it's not going to say hello back to me. It's going to say hello back to Concordia because it thinks that that's who's asking or saying hello to it. And Concordia will say, why are you saying hello to me? I didn't say hello to you. Okay? And Concordia will just drop it. And hello back are about the same size. So you can't really amplify that type of thing. Okay? That is how some denial of service works, where you just say hello with a spoof IP address and it says hello somewhere else. But there's no actual amplification there because the you saying hello and it saying hello back are more or less the same size. Okay, so this idea would work, but because there's this three-way handshake, it doesn't work. Okay, now does everything have a three-way handshake though? Okay, so network traffic, all the stuff we do on the web runs on a protocol that we call TCP. Okay, and TCP, the three-way handshake is part of TCP. That's where it comes from. That's the part of the network connection that's doing the handshake. And Yeah, and so like all HTML and web requests and all that kind of stuff, it all works on TCP. But there are alternatives to TCP, okay? So there's a protocol called UDP, and this just shows that TCP doesn't work because of the three-way handshake. Okay, there's an alternative to TCP, and TCP's alternative is called UDP. And with UDP, what happens is you just start sending traffic right away. There's no three-way handshake, there's no hello, okay? Why would you use UDP instead of TCP? And so the answer is sometimes you use it, well, okay, part of the problem with TCP is actually not the handshake itself, it's that TCP also comes with a bunch of other stuff. So, and they're really good things. They're things that you normally would want. So the first thing it does is it comes with packet ordering. So all packets will have numbers. And so I might send you 50 packets and you don't receive packet number 45, then you're going to say, I didn't get 45. You're going to come back to me and say, resend 45. Then I'm going to resend you 45, and your browser's not going to show you packet 46 until it gets 45. Okay, so it's going to order everything. All right, and that's really great in a lot of situations because a missing packet could completely bomb a website or a file or something like that. Like it could corrupt everything, right? But there's some contexts where you just don't care. Like I'm watching a video on Netflix and it starts dropping packets. That's fine, but I don't want to pause the video, wait for the packets to come back. Like if it gets blurry for a bit or like there's a bit of noise and then it just sort of skips ahead and then it keeps going, that's fine by me. Okay, I don't care about the packet loss. So that's the kind of thing that you might do over UDP. Another thing you might do over UDP is like things that are like really, really quick that it just seems kind of stupid to do a three-way handshake because the handshake will take longer than what you're looking for. So one example would be DNS. So I'm just like, give me Google's IP address. And then they send it back. Instead of saying, hello, hello, give me Google's IP address, and then you get the IP address, you just ask for it and they get it back. Okay, so these are the kinds of things that go over UDP. It's either some really dead simple information, or it's usually some sort of media streaming kind of example. Those are the two biggest cases for UDP. Okay, so the idea is with UDP, we can now do the spoofing attack. Okay, and in this case, I'll ask what's Google's IP address. I'll use a spoofed IP address for myself, and the DNS server that responds will respond back to Concordia instead of responding back to me. Okay? Now, the only problem with the DNS specifically as an example is that the response is more or less the same as the request, right? Like what's Google's IP? It's whatever, 8.8.4.4. It's more or less the same size, okay? So are there protocols that A, run over UDP, and B, the response is like way bigger than the request size. Okay, that's our wish list. If we have one of those, then we can do this amplification attack potentially. And so the answer is that yes, there are. There's a bunch of them, and people found them, and then once they find them, then people turn it off, and then they fix it, and then they find something else. And so it's this sort of game of cat and mouse that we're playing. But the earliest attacks used a protocol called NTP. And so NTP is basically like, hey, server, what time is it? And they'll say, well, it's 4:31 p.m. Eastern time. Okay? That in itself is not amplification. But that protocol, which is called NTP, Network Time Protocol, it runs over UDP, has other things that you can ask. You can say, hey, server, what are the last 1,000 people who asked you what time it is? And then it will say, here's 1,000 IP addresses of the last people that asked me what time it is. Okay? And that response is way bigger than the request itself. Okay? So what you do is you ask the server as fast as you can, what time is it, or who connected, and then it's like, here's 10,000 people, here's 10,000 people. And it's basically keeping up with the same frequency, but it's taking your message, which is whatever, I don't know the exact sizes, but they tend to amplify it by 10 or maybe up to 90 times bigger. And that traffic is now being directed to Concordia. Okay? And you don't have to use the same NTP server. So the NTP server, maybe it can't keep up. That's fine. You send some of your traffic to NTP A, and then you have another NTP. You have 100 NTP servers, and you're spamming them all like pretty fast as they can keep up, and they're all sending it off to Concordia. And then guess what? You can also ask your friends to do the same thing. So this isn't mutually exclusive with distributed denial of service, right? You can do it. You can get a botnet, and you can get 10,000 computers, and you can all do this kind of thing. And now you're really, hitting it with a lot of data. So NTP is an example. There's a protocol called, NTP is an example that runs over UDP. DNS is the other example that runs over UDP. Streaming is another example. And NTP had this functionality where you could basically ask for who connected to it in the past. And NTP is one of these protocols that was from the beginning of computers, the very first versions of Berkeley's Unix and stuff like that. It was that protocol, and almost all servers support it. And the servers that support it tend to be the mainframe computers, that Bell and Rogers and all these people that ISPs and stuff, these big servers, they support that protocol. So finding a protocol or a server that has a ton of bandwidth that you can exploit isn't that difficult because it was so common. But anyways, what people have done now is they've gone around and turned this off. So they might still support NTP, but they won't support this exact query, or they just turn NTP off completely because you don't really need a protocol where you can ask random servers what time it is. You could have dedicated servers that are just sort of time-serving servers. And then another example, a more recent one, is DNS is basically, there's no authentication on DNS, meaning that if I ask the DNS server what's Google's IP address and there's an adversary in the middle, like say Concordia's Wi-Fi router, it could just change the response. It could drop in a fake IP address, and then my browser will open that IP address instead. My browser will still say www.google.com, right? But I'll just be at a totally different IP address, and that could be a totally different website that's not Google. We'll talk about another protocol, the protocol that will do the attack tree that should try and prevent that attack. But anyways, people are like, okay, we need to sign our DNS records. We need to add digital signatures. The problem with digital signatures is they're big, right? The IP address is really small. The signatures are big. And the way DNS works is it's kind of distributed. There'll be one server that kind of knows all the .coms, another one that knows all the .cas, and then there might be your local, Concordia gives us our DNS server, but if it doesn't know the answer, it asks the .ca, and then the .ca server, it needs its record signed by VeriSign or ICANN, who runs the whole domain system. And so what you end up doing is you get these sort of chains of certificates where different people are signing off at different granularities. And the main point is that these certificates are 10 or 100 times bigger than the IP address itself. Okay, so it's another area where you could use this sort of amplification. Okay, and then the last sort of category is elevation or escalation of privilege. And this is another one that's sort of weird, but it more or less means that let's start with the idea of privilege. So privilege is basically what you're allowed to do and not allowed to do. Okay, so there's some rules. So for example, on Moodle, we have different roles. So the TA will have a certain role where they can mark your assignments, but students can't mark your assignments, right? I, as a professor, can add students or add TAs to the course, but you as students can't, right? You can see your own grades, but you can't see your other students' grades. I can see all the grades, okay? So we have a bunch of roles. So you can think of those as privileges. Am I allowed to see your grade? That's a privilege, and it's either yes or no for all of you. And then escalation or elevation of privilege is basically like an attack where you get more privileges than you're supposed to have. So the system wants you to have a certain set of privileges, and you don't get them. So I'm going to give an example which I really like. I'll tell you the gist of it now, and hopefully you forget it by the time we get to that example. But it's for me, it kind of illustrates. It illustrates it. So this is embedded into a much larger social engineering attack. But basically what happened is someone was trying to reset someone's account on Amazon, and Amazon kept asking them, well, what's the last 4 digits of your credit card? And the attacker didn't know the last 4 digits of the victim, right? But then they had a smart idea. They called up Amazon and they said, hey, I'm this person. I want to add a new credit card to the account. And Amazon's like, fine, you can add a credit card. That's great. I don't even know that you're that person, but I don't care if you want to spend money on our site. Like, who cares? So then they added that credit card to the account. Then they hung up. They called back and said, I want to reset my password. And Amazon said, well, what's your last 4 digits of your credit card? And then they said, the last 4 digits of the credit card that you just added. Okay? So that was a way around, like, they weren't the person. They weren't authorized or privileged to reset the password. They didn't know the information in order to reset it, but they found a different path where they first added new information, and then because they knew the new information, then they were able to reset it, right? Or another attack was like related is you can call up the cell phone company and say, I lost my cell phone, I have this new phone, and I want the number mapped to this new phone. I want the SIM card on this phone to match. I want all phone calls made to this number now need to go to this SIM card instead. And they'll say, okay, how do we know that you are who you are? Well, who are the last 3 people that called you, right? And so that's something that if you're the real owner of the phone, you would know that information. The attacker might not know that information. So what does the attacker do? Well, they call that number 3 times, right? Then they call and say, I lost my cell phone. And they say, well, what are the last 3 calls? And they're like, well, I know the last 3 calls, right? Because I did them themselves, okay? So those they're kind of like corner cases or ways around policies in order to do things that you're not authorized to do. Again, this is like pretty modern stuff. So like a lot of attacks, like most operating systems now, you don't have admin rights. So I do something to your computer in the course of you using it. I want to get malware on your machine. That's fine, but I can't really change the operating system because you yourself cannot do it without like elevating your privilege to super user, right? So if there's some complicated thing that I can do that give me that privilege, right, then we would call that an escalation of privilege attack. So most malware nowadays will have this at least as a component because one of the things you have to do is sort of get around the fact that no one's like sort of admin on their machine by default. And so, yeah. Okay, so just to recap Stride, as you can imagine, it's very high level, but what it is useful for is just sort of a starting point. Someone hands you something and you're like, okay, what are the attacks against it? At least you have somewhere to start. You can say, well, what are all the attacks on the spoofing of the system? What are all the tampering attacks I can think of? What are the information disclosure attacks? And then go through all the lists. And then you can start brainstorming them. And then you can start thinking about how to protect them or how the system already protects the attacks or protects the system against those attacks. Okay, any questions about Stride?
So I didn't get the 3-way hello.
The which?
The 3-way hello.
The handshake? Yeah, so I didn't explain it very well. Basically, before you're allowed to talk to a server and ask, like say I say, what's index.html, I do this protocol where I say hi to the server, it says hi back, and then I say, give me index.html. Yeah, and the reason it breaks down, it's meant to prevent IP spoofing, and the reason it breaks down is I can say hello to the server and spoof this IP address. So this isn't the adversary's IP address. This IP address actually belongs to Concordia. So it sends a message. Just think of it like mail. Like I mail something and I put the return address, but instead of putting my address, I put your address. Yeah. So then the person gets it, and then when they reply to you instead of me. The problem with the handshake is I say hello to the server. The server says, I received your hello back, right? And Concordia gets this message out of nowhere. And it didn't say hi to the server first, so it doesn't know what this message is. It just looks like spam, and so it just drops it. Does that make sense? Yeah, okay. It would have to say hello back to the server. Yeah, to the same server, and then the server then you could ask for the index.html. Okay, other questions?
The example that you said about the Amazon and the credit card, like you called that, for example, the attacker called the Amazon and they said that I want to add this credit card to this account.
Yeah.
Is it feasible in the real world, or is it just a hypothetical?
So that was something that happened in real life. So I'll tell you the full story of it when we talk about social engineering. There's a whole article that goes along with it, but that was like part of the attack. It was a much broader attack, but no, it was something that literally happened It was on the front page of Wired magazine, which is a very popular tech magazine. And then Amazon, of course, changed their policy right away. Right, so you can't do it today. But there are these kind of books, like people who do this social engineering stuff, they'll write manuals about, this is what, for every company, like you just look up Amazon, and it'll be like, okay, you want to do this is what they ask for. You want to do this is what they ask for. And then you try and find ways of weaving through and getting what you want. So that's one way, like in that case, like nobody did the wrong thing, right? Like the person on the phone from Amazon, they follow what the policy is and things like that. The problem was with the policy itself. Some social engineering is I just straight up tricked you, right? I say, hey, I'm calling from this other division of Amazon, and I really need these last 4 credit card digits because, I don't know, my computer crashed or something like that. You believe me, and then you tell it to me, so I like kind of tricked you, right? So anyway, so there's different ways of doing escalation of privilege. One is outright tricking someone, but in this case, no one really got tricked. It was just the policy. Whoever wrote the policy didn't think it through what they were doing. Yeah. So we'll examine both. We'll look at it from the policy side, and we'll look at it from the social engineering side. Yeah. Okay, other questions about Stride or anything? Okay, so that's it for today. And, oh yeah, one last question. No problem.
We are supposed to now, having learned this act, and then we're applying it to the system, a scenario policy, all of those different.
Okay, I know I said it's the last thing, and so everyone's like excited, but let me answer the question and then we'll go. Okay, just 2 more minutes. Yeah. Okay, so what do I do with this? So maybe I should have had a better wrap-up slide. The point of this is, actually, we're going to come back to Stride. So when I go through evaluation frameworks, when I go through attack trees, we'll keep revisiting, like, oh, this is an example of spoofing, or this is an example of tampering. So yeah, right now I didn't really tell you what to go and do with it, because I know the whole course, and I know that it's going to be a recurring theme where we keep seeing these kinds of attacks over and over. And the more practical question might be like on an exam or something, like, what am I going to ask you about this? I already said, well, maybe you don't care, but anyways, let me answer that question anyway. Yeah. So like for a project or real world, you get a job or that type of thing. Again, it's just a starting point for brainstorming. So when you start looking at the security of something, you want to make sure you're looking at it from all possible angles. And so it's a way, especially if you get kind of narrowly focused, like I know all about networks, so I see everything as a network issue, and I'm not thinking about like escalation of privilege or I just think about denial of service. That's the only thing. And so a lot of real world systems, there's different ways of breaking them, or there's different properties. And so this is also meant to kind of get you thinking beyond just what your expertise is and trying to think holistically about the security. But the way you apply it is basically it's just a pure thinking game, or maybe you do it with some other employees or other students. You kind of get around a whiteboard and you just are like, okay, here's everything I can think of in terms of spoofing. Here's everything I can think of in terms of tampering. And then once you're done with that list, then you need to start addressing those, and you're not going to use Stride anymore. It's just going to get you that initial list. Cool. Okay, other questions? All right, sounds good. So I'll put a recording of this lecture, like all lectures, on Moodle, and I'll see you all next week.